Welcome to today's tutorial. So in this tutorial we're going to discuss how to find the inverse of these given functions here, and also how to find the domain of the inverse of these functions. Alright, so if you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button and the notification button so that you don't miss out the videos that I'm going to be posting. And also make sure that you send all your questions to the contacts on the screen here. Okay, so finding the inverse of any given function is straightforward. So if you have been given f of x here, you can use f of x, but sometimes it becomes too cumbersome. It becomes, your work will be bulk. In short, you are going to write a lot of things if you use f of x. So to simplify things, we equate f of x to y. So we say let y be equal to the given function this side. Then make x the subject of the formula. That's the next step. So you make x the subject of the formula. So we're going to take 8 to the other side of the equal sign, and we're going to have y minus 8 is equal to x to the power 3. So this can also be written as x to the power 3 is equal to y minus 8. So to make x the subject, we're going to find the cube root of both sides. So x will now be equal to the cube root of y minus 8. So f inverse of x will therefore be equal to the cube root. While there is y here, I'm just going to replace with x. So the cube root of x minus 8. So this can also be written as x minus 8 in brackets to the power 1 over 3. Still the same. So we're going to do the same even for the second part. Before we can move on, let's see how we can find the domain of this function. So the domain is simply just all real numbers, because a cube root function has no restrictions. So the domain is simply just all real numbers. Okay, so let's move on to the second one. This one. First I have to find the inverse of this function. So likewise, I'm going to equate it to y. Say let y be equal to 1 over x squared minus 2. So I'm going to take this negative 2 to the other side, so that I remain with 1 over x squared this side, and then this other side I'm going to have y plus 2. So when I cross multiply, I'm going to have, now cross multiply, this goes this side, and then this one comes down. Or let me first cross multiply them. So I'm going to have 1 is equal to x squared open brackets y plus 2. Then from there we can now make x the subject of the formula. So making x the subject of the formula, we're going to have x squared is equal to 1 over y plus 2. That is after dividing by y plus 2 on both sides. Then making x subject to be therefore equal to the square root of 1 over y plus 2. Okay, so the domain of this function, before we find the domain, let's write this in this format. F inverse of x is equal to 1 over the root of x plus 2. So we're going to have the square root of x plus 2. So the domain of this function is, we know to say the denominator in any radical function should never be equal to 0. In any rational function rather, the denominator should never be equal to 0. And then for a radical, we know to say whatever is under the root should also never be less than 0. Should never be a negative, in short. So what that means is that find the domain of this function. First of all, we're going to equate the root of x plus 2 to 0. So when you equate this to 0, we're going to have x plus 2 is equal to 0. So meaning, first of all, we need to know that when you take this to the other side of the equal sign, we're going to have x is equal to negative 2. So we know to say this expression, which is just the denominator of this radical function under the square root, we know to say this should what have I done? Okay, it's supposed to be like this. It's not supposed to be like this. Okay, there's just supposed to be one square root, so meaning this is not supposed to be part of the solution. So in other words, let me write it here. It's supposed to be like this because the square root of 1 is simply just 1. So f, let me write it here, f inverse of x is supposed to be equal to 1 over the square root of x plus 2. So when you equate the denominator to 0, we know to say the denominator is not supposed to be equal to 0. So meaning, we do this, meaning x is not supposed to be equal to negative 2. When you replace negative 2 as x, you are going to have the denominator as 0. 1 over 0 is undefined. So meaning, in the domain of all real numbers, we have to exclude negative 2. And then not only that, we know to say for the radical function, anything that is under the root should always be greater than 0. So should always be greater or equal to 0. So we know to say x plus 2 should be greater or equal to what? 0. So when you take this to the other side of the equal sign, we have x should be greater or equal to what? Negative 2. But we know to say x is not supposed to be equal to negative 2. So in other words, the domain is simply just x is greater than negative 2. It should not be equal to negative 2. Yeah, but it should be greater than negative 2. So we've just removed the equal sign from this expression. So meaning the domain of this function, rather the domain of this inverse function, is simply just x greater than negative 2. So you can replace any value of x in this expression except any number that is negative 2 going down. So the number that you are supposed to replace here should always be greater than negative 2, and this function will be defined. Alright, so let's quickly move on to this one. So for this question here, finding the domain of this function, we first have to find the inverse rather. Finding the inverse of this function, you just take this 4 to the other side of the equal sign. Let me demarcate, or let me start from here. So we have y is equal to x squared plus 4. So when you take this 4 to the other side, you get x squared is equal to y minus 4. So the value of x will then become the square root of what? Y minus 4. So this, so this will now be equal to, so in other words, f inverse of x will now be equal to the square root of x minus 4. So here we are given this condition to say all the values of x that you are putting into this function should be what? Should be greater or equal to 0. So the smallest value of x should be 0. So when you put 0 there, you are going to have negative 4 as your output, which is just the range. So meaning the values that you are going to get will always be greater than or equal to 4. That is the range of this function. So now let us try to find the domain of this function. So the domain of this function in most cases is actually the range of, not in most cases, always, it's a range of the main function. So the range of the main function, remember I said it's supposed to be 4 going up. The answers will always be greater than 4. Let's see if that's true. I was just trying to find the range as quickly as possible. That is simply the domain of this function. So let's find the domain of this function. We all know to say everything that is under the root should always be greater or equal to 0. So we know to say x should be x minus 4 should be greater or equal to what? 0. So when you take this to the other side of the equal sign, you get your x greater or equal to what? 4. So when you check this expression, you check this domain here, is exactly the same as the range which I talked about here. The smallest value of x you can put in this expression is 0 according to the expression. So when you put 0 there, meaning the smallest value that you're going to get will be 4. Then whatever you're going to be putting which is greater than 0 will give you any number greater than 0, meaning we're saying the domain, the range rather, is simply just x is greater or equal to 4. So this is what I've found. So this is the domain of this function. Alright, so this is how you deal with such questions. Thank you very much for watching today's tutorial. So if you have any questions, feel free to contact me on the lines that I showed you at the beginning, and make sure that you don't forget to subscribe to the channel. My name is Hamted. See you in the next tutorial video. Shalom, shalom.